All right, so today we have notes 1.3, percents versus decimals. So whenever we see percents are always going to be geometric, and you must change them to a decimal. So if you want to underline or highlight that, please do. Decide if it's an increase or a decrease decimal as well. This is going to give you your common ratio. So if you have an increased percent, that's 1 plus the percent. But remember, you have to change it to a decimal first. If it's a decreased percent, you have to do 1 minus the percent. And again, it has to be changed to the decimal. All right, so we're gonna do examples. So Miss R has way too much candy from Halloween. Her big flirty son got all the candy in the neighborhood from the neighborhood moms. Miss R has a pile of 100,000 candies, and she generously plans to give away 60% of the candy each day. So let's talk about what's important. All right, so we know she has a pile, which is times 0, and that pile has 100,000 candies, so that's our start. And then we also know that she plans to give away 60%. We're talking about percents, which means it's going to be geometric, okay, because we're talking about percents. And we have 60%, which we have to change to a decimal. You start at the right side and move left to 2, and you get 0.6. Okay, now we have to determine, is it an increase or a decrease percent? Well, if she's giving away, that's a decrease. So that means we have to do 1 minus 0.6, which gives us 0.40, and that is our common ratio. Okay, so let's write our recursive. We know we're multiplying by 0.40. We just figured that common ratio out over here. We know our start time is times 0 because she just has it. It doesn't give you a day or anything. And then she has 100,000 candies. So that's 5 zeros, y'all. So now it's time to write the explicit. So the explicit, remember, you start with your first start number. So that's 100,000. Then you write your common ratio, which is times 0.40. And then we are timesing by 0.40, so that means we're going to be using an exponent. So we're going to have an exponent n. And since we start at times 0, it's just going to be an n. Now we have to figure out how much candy she's going to have on day 5. So here's we're going to use the explicit. So let me write this out real quick. All right, so it says how much candy is she going to have on day 5. So day 5 is our new time. So that means we're going to have f of 5 because we're replacing n with the number 5. And then we're also going to replace this orange n with the number 5. Make sure it's still an exponent. So what I'm going to do is I'm going to take these numbers right here. I'm going to type them into my calculator exactly. Make sure you have 5 zeros. And make sure to use this button as your exponent for your 5. And we get 1,024. So this is saying on day 5, she's going to have 1,024 candies. So that would be our answer for this. Let's look at the next one. Mr. R loves to eat candy at work, but he's kind of a weirdo and will save some of his candy for the next day. Ew. Mr. R bought a 300-piece bag of candy for work for the first day of October. Each day after he bought the bag of candy, he eats 3.25 pieces of candy. So let's go through the stuff that we know. So I know that's the first day, so that's going to be time 1 because it's the first. We also know that on that first day, he has 300 pieces of candy, so that's our start. And then each day after, it says he eats 3.25 pieces of candy. Does this say a percent? It does not, so it's arithmetic. There's no percent, okay? Now, if he's eating candy, is he gonna have more or less? It's gonna have less. So we got minus 3.25 and this is going to be our common difference, okay? So when we write out the recursive, we're gonna have f of n equals f of n minus 1 minus 3.25. Our start time we said was 1. So we have f of 1 equals, and he started with 300 pieces of candy. So when I write my explicit after that, I start with my start number. We started with 300 pieces of candy, and then we're minusing 3.25 each day. And then we have to write our variable after our common difference, right? So I'm gonna write an n, but I'm not gonna write just an n. We start at time 1 and we do the opposite. So I have n minus 1 next to my common difference. Now, it asks us how much candy he will have on day 5. So I'm gonna write out the explicit equation. Okay, so I rewrote my explicit equation, but instead of n's, I wrote 5's because we're on day 5, right? So we're changing the time. And I'm gonna take this part of my equation and I'm gonna type it into my calculator exactly how I see it. This gives me 287. So on the 5th day, he's gonna have 287 pieces of candy, okay? All right, let's look at the next example. Okay, so our next example, there's this little love note in your notes. It says, if you're not sure what math is happening down a table, right? Because here we might not know. What you're gonna do is you're gonna do the second number divided by the first number, which it would give you the common ratio, or you would do the second number minus the first number, which would give you your common difference. Now, the most important thing is you gotta check if it works. So if you try, dividing first and then you get a number, check that it's gonna work as you go down your table. Same with this side. So a prairie dog reserve was established on 120 acres of land in 2015. As the surrounding land has been bought slowly to increase the prairie dog reservation. So looking at our table here, see how we have more decimal places? This means we're probably using a common ratio. So we should do the second number divided by the first number, okay? So 144 is my second number, 120 is my first number. So I do 144 divided by 120 and I get 1.2. So I'm gonna check that multiplying by 1.2 is the math we are doing down our table. So I'm gonna use my calculator and I do 120 times 1.2 and I get 144. Then I do 144 times 1.2 and that gives me 172.8. Then I do that again, just double checking that everything is still working. And I get the correct answer. So we are multiplying by 1.2 as we go down our table. So again, you take your second number, dividing by your first number, and that gives you a common ratio. And since we have a common ratio, this means that our sequence is geometric and our common ratio is multiplying by 1.2, okay? So let's fill out our recursive and explicit. So we have for our recursive, we have f of n equals f of n minus 1 times 2, which is what we're doing down our table. We start with a 1, and we also start with 120 acres, okay? So when I write my explicit, we write what we start with in acres here. So we started with 120 acres. As we go down our table, we are multiplying by 1.2. And then since we're multiplying, we're gonna have a variable our variable is going to be an exponent, so I have an exponent n. But since I start with a time 1 here, that means I have to do n minus 1 in my exponent. So there is my recursive and my explicit. The last problem here, we go from 120 to 112.5 to 105 to 97.5 to 90. So because it keeps flip-flopping how many decimals it has, which is different from what happened here, it's probably going to be a common difference. So this means we should do our second number minus our first number to get our common difference. So when I do 112.5, my second number, minus my first number 120, I get a negative 7.5. So basically that means as I'm going down my table, I'm minusing by 7.5. So we're gonna check that. So 120 minus 7.5 gives me 112.5. 112.5 minus 7.5 gives me 105. Okay, this is working out. 105 minus 7.5 gives me 97.5. So this is good. That means this is my common difference because it's working. So if I'm got a common difference, this is arithmetic, and I'm minusing by 7.5. Okay, so when I fill out my recursive, again, always starts as f of n equals f of n minus 1. Then we minus 7.5. And this gives us a start time we started with a 1. We have 120 acres, so we have f of 1 equals 120. When I write my explicit, I start with that 120, remember, because you always start with what you got first. Then you write your common difference, which in this case was minus 7.5. And then after minus 7.5 is what we do for our variable, right? So we have an n, but we're not going to have just an n. We're going to have to do n minus 1 with parentheses around it because we started at time 1 and we always want to do the opposite. That's the end of this video. So if you would like to get started on your exit ticket and your homework, go for it.